How's it going? So, if you're watching this, you may or may not be interested in a project I'm working on. It's a Q&A chatbot. That's the best way I can explain it. It's specifically for any PDF that you want to upload. This was just a dummy project to kind of get started with learning large language models. Let me just share my screen so you understand what I'm talking about. So this is the README right here. Over off to the side here, you can see I'm using Phi 3.5 mini instruct. This model is off of Hugging Face, as you can see here. And it's specifically for CPU-based workloads. So this app is going to be very, very slow because while I have a nice, powerful AMD 7 Ryzen chip on my laptop, it's still a laptop CPU, and it's not using the GPU that's on board. I haven't quite gotten to that level just yet. There's a lot of configurations that would have to go into making that work. Just walking through the code a little bit. So there's two main things that are interesting here, or three actually. So firstly, I have this PDF Q&A server file. This file, it does two things. It interacts with the UI here. So for example, if I decided to upload a PDF to the platform, it would go through and tokenize all of the text inside of the PDF and create some embeddings. And as you can see here, we're just straight up extract the text from the PDF and then get all the embeddings and then batch them together. And we're also going to want to post it to the storage that I have set up, which that takes place in this file here in the embeddings file. So this server, PDF Q&A server, calls this embeddings server file. And in here, we're essentially just calling the Qdrant database that I have set up. So if you check this Docker Compose file here, and all this will be available on the repo, on the GitHub repo, we have the Qdrant database available, and it's, as you can see, we're setting up the host and a Docker storage container, right? And so that embeddings, that's how it batches everything together and posts it on the vector database so that it's actually useful. And then also, if this is the interaction with the client for the most part, so as you could see here, this file in PDF Q&A server.py, here we have the local AI URL. So if we go back to Docker Compose, as you can see, local AI is how we're spinning up the workspace for the Phi 3.5 mini instruct model to run. So local AI is essentially the runtime that allows the model to run locally on your machine. So everything for the Qdrant and the local AI is inside of a Docker image. Everything else is running on the host machine. So all I need to do to get this up and running is Docker Compose up build, and you can see that was fast. It spun up the Qdrant database. So let's do this really quick. It spun up the Qdrant vector storage or vector database, and it's also spinning up the local AI instance along with the models that I already had set up. So if this is working the way I think we should be able to ask it just like a basic question and start to see some output here. How is your day going? So as you can see, the AI is starting to process the question. And right here, if you can see this, we're doing this is specifically expecting a PDF file to run and to query against the LLM. And as you can see, it's already done. It's already given us an answer for how's your day going. So from here, I am going to upload a PDF file. One of my favorite books, Eric Rye's The Lean Startup. So as soon as I drop it in here, the system is immediately going to try to process it. So I'm just going to drop it in. I'm going to switch over. So as you can see, already it's processing the page, and it's actually quite fast for a CPU bounded model. And it's already processing the token chunks, and it's creating embeddings in real time. Super cool, right? This is awesome. Again, this, because of the nature of WSL on Windows and Docker, it's going to be a lot slower than just using a normal GPU. But the fact that it's already got it running and I'm streaming, or excuse me, recording, that is super cool. And CPU usage is pretty low. So if I go here, so it's already processed the model. Now, if I ask it a question, so hold on, let's see, from the upload time, I just wanted to see this. So 14 uploaded it at 57:30, so it got it done within, what was that, 20 seconds? Yeah, 29 seconds. Not bad. Before, it was taking like closer to like 45 seconds to a minute. Now that I've selected this entry here, the PDF file, let's say, who is the author of the Lean Startup? Now it's going to process it. Now, because as you saw before, the system is taking all of the chunks and it's going through and measuring the question against those chunks to produce the answer context. So this might take a second. I will probably cut to when it's working and compare the times, like right here, as you can see. We'll compare the times. Actually, it's already, wow, let's see. And then it already streamed the response. I was not expecting that because usually it takes longer. So I'm gonna ping it with another question. Top 5 takeaways from the book. Please give me the top 5 takeaways from the book summarized in bullet points. All right, so it's going to go ahead. Again, it's chunking through it. It's querying with the context. It starts at 15:01, so 3:01 at my time. And yeah. So we'll check back in once it's done, and we'll see how long it took. And yeah, look at that. It's already processing it. Now, I've read part of the book. I haven't read the whole thing, but already it's talking about embrace learning and experimentation. MVP, that's cool. Validate ideas early. This is great. Both of those concepts are early in the book. I'm trying to remember. I think it's that's chapter 1 and chapter 2. After that, my knowledge breaks down. This is super cool. So if we check, it's just directly interacting with the back end here, and it's just streaming the response. I wish I had put together a way for you to be able to see the streaming back down, but that is awesome. So right now, it's just slowly bringing out the text to the user interface. Now, this would be much faster if the GPU was up and running and if I had gotten it, but it's almost done. Oh, this is so cool. The fact it can query on a PDF file that you give it is so cool. And it's chunking, and it shows all of the chunks that we worked with. Super cool. Now, let's take a look. So we queried the LLM and context in question. The streaming took 2 minutes. 2.5 minutes, roughly. That's cool, because before when I was running this, I hadn't really played around with the model to get the most out of the CPU. This took like 5 minutes to get a 5 bullet point takeaway from that one PDF file. So that's pretty cool. So yeah, this is my little project. Next steps would be to update the model, either with something faster or can play with the configuration so it can run the GPU, because there's a problem with I'm using WSL for Windows Subsystem for Linux for development, and there's some issues with the Docker instance and the WSL not being able to access the GPU. So there's some modifications I can make, either run the model locally with Python or just incorporate maybe Podman. We'll see. But yeah, I wanted to show off the fact that I've been able to get it to run. Yeah, you'll see a link with a link to a course that I took to start doing this. Really great content. It's a Skool community with tons of support. Zen Van Riel, I'll also drop his YouTube channel in the description as well, because he kind of put me on to this, and well, if you look at the course, you might see some similar stuff. Don't hate me too much. But yeah, no, this is awesome. The fact that I was able to get this up and running. I just wanted to show it off because this is super exciting. I think this is cool. If I get it running with a GPU, man, oh. Anyways, had to show that off. So if you took the time to watch this and you saw it all the way through, thank you so much. Have a lovely day.